Hi, let's look into this problem. Find the differences of two arrays. So this problem states that we are given two arrays. We need to find the differences between them. That is, if you see the example 1, array 1 is 1, 2, 3, array 2 is 2, 4, 6. So if you see 1 is not there in array 1, so here's the 1, and 3 is not there in array 2, and here is the number 3. In the similar way, the opposite direction as well. So if you see array 4 is not there in array 1 and 6 is not there in array 1 and respective elements are there in this. How you can solve this problem? What is the brute force solution that comes to our mind? I will come to a traverse array 1. For each element of array 1, I will traverse all the elements of array 2, and if that element is not there, I will append that in my solution. Okay, the similar way I will do the opposite direction as well, the other way around as well. I will, for each element of array 2, I will traverse all the elements of array 1, and if that is not there, I will put that element in my answer to list. So here, wow, what would be our time and space complexity? Time complexity would be n into m square, where n is the number of element in array 1 and m is the number of elements in array 2. N into m, 2 times n into m, because we are doing it 2 times. So is there a way to optimize it? Yeah, we can optimize it. How? So how we can optimize it? We want a, what do we want here? We want to know which element is present in array 2 in constant time. How can we do that? We can use the data set called hashmap or set. I have used hash set, which actually tells us, gives if the element is present or not in constant time. Okay, so we can use hash set, and we can decide for each element of array 1 the same element is present in array 2 or not. So how I am doing it? So if you see here, first of all I'm constructing the hash set. What all numbers are there in my array 1, what all numbers are there in my array 2. I'm creating that hash set. This will help me in getting the number of element constant time. Okay, now for each element that are present in the hash set, so there is one more example. If you see here, we have 2 times 3, but the expectation is we give only 3 as a difference, not 2 times 3. That's why what we are doing is we are traversing the hash set. This hash set has one more speciality. What it says is, it just stores the element once. Same like your hash mark, the key will be stored only once. So the numbers will be unique in your hash set. So what I'm doing, so we are just traversing the hash set for each element of hash set of one number of element that are present in the hash set 1. I'm comparing it with hash set 2, and this is a constant time. Usually what we would have done at this place, what we would do is we would traverse all the element of array 2. Instead, we are just getting this in constant time. Okay, just getting it in constant time, and if that is not present in our hash 2 element, we are just appending that in our array answer list. Okay, the similar way we are doing that in doing that for hash 2 as well. So what is the time and space complexity for this? Time complexity would be, for generating O of n plus m, this is O of n plus m, and here also we are traversing 1 times, here we are checking in constant time. Yeah, and one more thing here is we have different types of hash set for this. Let's say if you use tree set, the time complexity is different. If you use there's some more set, if you use that, the time complexity would be different. So I've used hash set, which is retrieving the element is retrieving is a constant time in this case. So if you use tree set here, let's say retrieving would be a log n time, right? Yeah, it would be a log n. I'm not exactly sure if it's a login, yeah, but retrieving around login if you use tree set here. It is basically how the data is stored in the data structure. So I have used hash set, so it will be stored like an hash map, which is retrieving is a constant time. Okay, so this is of n, and in the worst case of n versus of m. So the total would be of n plus m, which is of n constant time. And yeah, and importantly, space complexity in the worst case is of n of n, because we are storing all the elements again in our separate hash map, right? Yeah. Thank you.